What conclusion would you draw from the following graphs for an ideal gas? Notice that the given graphs are pressure temperature and volume temperature curves, and both of them are straight lines, with the intercept on the x-axis being at 0 Kelvin. So the first statement says, as the temperature is reduced, the volume as well as the pressure increase. Temperature is reduced implies that we are moving in this direction. And notice, as we move along this direction, the volume is being reduced, and same is the case with pressure. That is, it is not increasing. So this statement is incorrect. The second statement, as the temperature is reduced, the volume becomes zero and the pressure reaches infinity. Now if you again look at the graphs, for volume, yes, it theoretically does reach zero as temperature is reduced. However, the pressure is also reaching zero as temperature is reduced. It is not going to infinity. It would go to infinity when pressure is increased. Okay, so this statement is also incorrect. As the temperature is reduced, the pressure decreases. Now this statement is correct because as the temperature is reduced, we are moving towards this direction, the pressure is also reducing. A point is reached where theoretically the volume becomes zero. So if we look at the volume temperature graph, there is definitely a point over here where the volume is zero. That is, the value of y is zero. And notice that this can happen only theoretically. In practical reasons, zero volume makes no sense. So this is basically an extrapolation of the graph. So this is also an answer. So our answers for this question would become option C and option D.